to pre-calculus honors. Glad to be back.
All right, so this is where we left off yesterday. What we're going to do here is we're going to solve the same system of equations as we did in example 1, but this time we're going to do it using matrices. So the first thing we're going to do is we're going to put this in an augmented matrix. So here we have 5, -5, -5, 35, -1, 2, -3, -12, 3, -2, 7, 30. And here we have a vertical line. You can make it dashed or solid, I don't mind. This is called the augmented matrix. So you have the coefficients here on the left side, and this column is the constants. Okay, same thing as above. What I want to do at the end of the day is I want to have it such that this diagonal is all ones and everything underneath the main diagonal is a 0. Okay, so the first thing I'm going to do is multiply or divide this row by 5. Okay, so I say 1 over 5 times row 1, and I get 1, -1, -1, 7. The rest will remain unchanged.
Are we allowed to do like multi-step?
Yes, you are allowed to do multiple steps in one. I just ask that when you're doing this, make sure you're concentrating. Do not try to multitask, because one tiny little mistake will just snowball and it'll make even a simple solution into a very, very complicated and difficult one, okay? And wrong, I might add. Okay, so here I said in my tips and tricks, and that's what this is. They're basically tips and tricks. Start with the entry in the bottom left corner, so this one. Start by making that a 0. And then I move to the one right above, okay? And then I move to the one to the right. Okay, so that's the order that I like to do it. Now, I want to get a 1 here. Okay? So, here are a couple of more tricks that you can do. You're totally allowed to interchange rows. Okay? So, if you think 2 steps ahead, okay, if this row, the second one, was at the bottom, all I would have had to do is add the 2 rows and I'd get a 0 here. Okay? So what I'm going to do is interchange row 2 and row 3. So here's what I'm going to do. Row 2 and row 3 are going to get interchanged like this. Okay, so the first one stays. And here I have the bottom row. Now, what I'm going to do is I'm going to replace the bottom row with the sum of row 1 plus row 3. So I'm going to add row 1 plus row 3 and replace the bottom row here. And I get, when I do that, 0, 1, -4, and -5. Okay, so now I have my 0 there. The next thing I wanted to do was do what? I wanted to get a 0 here, right above. How can I get a 0 there? What can R1 plus R3, because this now became R3. Right. So now what am I going to do? How can I get a 0 above this 0? So go back to this matrix, the one, I'm going to combine steps in one procedure here. So what do you guys think? Anybody have any ideas for me? And add it to row 2, right? Okay, so here's what we're going to do. Row 2 plus 3 times row 3.
Should it
Well, it's already negative.
Oh, sorry, I was looking at the wrong.
Okay. So row 2 plus 3 times row 3. All right, so it's going to be 3 minus 3, that's 0. Negative 2 plus 6 is 4. 7 minus 9 is negative 2. 30 minus 36 is negative 6. Okay? Now let me just put that other row back. Okay? Now all I need to do is make this into a 0. I also have to divide this and make it a 1, right? By 4, actually. All right, we're going to catch people up here. So I want to get a 0 here, okay? So I have to do this row minus 4 times this row. Row 2 minus 4 times row 3. Here, I get 0 minus 0, so it's just 0. And that's the reason why I'm adding these two. Because if I added row 3 to row 1, I would have reintroduced a digit here, which I don't want. Okay, now here, you have to be cautious and careful. All right, row 2 minus 4 times row 3. 4 minus 4 is 0. Negative 2 minus 4 times this. Negative 2 plus 16 is 14. And now here I have 6, negative 6 minus 4 times negative 5. There is nothing wrong with writing it down. You don't have to do it in your head. You're not going to have a 4-function calculator either, okay? So 20 minus 6 is what? 24? Why is there? I don't know.
It's negative 6 plus 1.
My bad. The wrong number.
Oh, it's 14. 20 minus 6 is 14. Okay, now,
Oh, look at what we have here.
amazing. So now, is this in row echelon form? No, it's not.
Comparison.
You're wrong.
Of course not.
Now, I need to make these ones, okay? So what I'm going to do is I'm going to do 1 over 4 times row 2, 1 over 14 times row 3. So this first row remains unchanged. Here I get 0, 1, negative a half, negative 3 over 2. Yes, you can have fractions, as long as it's correct. 0, 0, 1, 1.
Is decimals also accepted?
I like fractions.
Is that a matter of opinion or grading?
It's a grading matter. Okay, so this is your matrix in row echelon form. Okay? Now, what does this mean? Okay? When we initially set up our matrix with our coefficients, if you look at the first column, 5, negative 1, 3, these are all of the coefficients of the x's, right? So this is the x column, this is the y column, and this is the z column. That means here, this is the x column and the y and the z column. That also means if you take each row, here's how you read it. 1x minus 1y minus 1z equals 7.
Oh, you're good.
1y minus half z equals this. 1z equals 1. Okay, so from here we get that z equals 1. And now we can back substitute.
Oh my god. Y equals negative 3 over 2.
So y minus 1/2 equals negative 3 over 2. Okay, and if you add a half,
You get 2. Oh no, my bad.
negative 1, because it's negative half plus a half.
I saw positive.
And then, so y equals negative 1. So here, the first equation I have from row 1, I have row 1, x minus 1 times negative 1 minus 1 times 1 equals 7. So x plus 1 minus 1 equals 7. So x is equal to 7. So my answer is 7 minus 1, 1. And hopefully that's what we had gotten before. Right
This isn't actually
there.
I actually prefer this in matrix C form than I do the other stuff. Does this get like way faster when you start like combining steps? Because it's like still kind of slow.
All right, what we've been doing until now was Gaussian elimination. And we were using Gaussian elimination to put a matrix in row echelon form. Meaning, the goal was to get the main diagonal to equal 1 and everything underneath to equal 0. And we stopped right there. Well, technically, that's only half of a process. You can continue the process. Until here, this is Gaussian elimination. You can continue the same process of getting zeros in order to get zeros in the triangle above as well. So in this spot, this spot, this spot. So it's the, listen, so it's the same procedure. You just continue 3 more steps, okay? And what you get is a diagonal of 1s and everything else is 0 above and below, okay? That is Gauss-Jordan elimination. Jordan is the last name of another mathematician who, in conjunction with Gauss, came up, with an extension of all of this. So,
It looks like binary.
so if we continue the process, okay, we can also eliminate the entries in the upper right-hand corner. What we were doing before was called row echelon form. When we also eliminate the ones above, we get reduced row echelon form. Okay? Basically, you get 1s here and 0s everywhere else. Okay? And this will be your, you have like constants here. And when you do that, the beauty of it is, you can just look at this matrix and you can say, okay, x is this number A, y is this number B, z is this number C. You see what I mean? Okay. So here we're going to solve this one using Gauss-Jordan elimination. The process is the same in the beginning. So let's start. The matrix is 1, minus 1, 1, 3, negative 1, 2, negative 1, 2, 2, minus 3, 3, and 8. Okay? Now, so the process is the same, and I will try to not combine steps. What I want to do first is I want to get a 0 here. Okay? Now, you can, if you wanted to, switch these 2 rows, but I'm not going to in this one. Okay? So, how can I get a 0 here? Yeah. 2R2 plus R3. So 2 times row 2 plus row 3. Okay, so everything else will remain unchanged except for this one. So I'm going to get 2 times the second row, negative 2, plus this one, 2 is 0. 2 times 2 is 4, plus negative 3 is 1. Negative 2 plus 3 is 1. 4 plus 8 is 12. Okay, next. Yeah. Yeah. Yes. So now for the next one, I want to change this. Okay, so I'm going to add R1 and R2. And I get 0, 1, 0, I'm now,
Doing R2.
Oh, okay.
and then I'm going to fill in the rest, and then 5 here. So the first and the third row remained unchanged. Okay? And, all right, let's see what we're going to do here.
I'm confused. How are we allowed to have a 0 there?
Huh?
How are we allowed to have a 0
Well, eventually you're going to get zeros everywhere. So this is actually pretty good because I just want ones at the end here and zeros everywhere else. Now, the next one I want to do is this. And to do that, all I have to do is, right, or I can do R2 minus R3. Okay? So let me just copy over the first 2 rows, and it'll be 1 minus 1, another 1 and 3, 0, 1, 0, 5. And here, so I'm subtracting, right? So I'm going to get 0 and minus 1. And 5 minus 12 is negative 7.
Wait, what did we do?
Wait a minute. Okay, hang on. So here what I did is row 2 minus row 3. Okay. Next, I'm not allowed to have a negative 1. So I'm going to divide. But, okay, so in this case, I am going to combine steps because it's a waste to do it otherwise. Okay, so what else do I need now? These are okay. I now have to switch out these 2. Okay? All right, so the next one I'm going to do is this. The next one I'm going to do is this. I want to get a 0 there. For
Can't we just do R1 plus R2 and just get 0 out the bottom? Or can you do R2 plus
Okay.
R1 minus R2 plus R3?
So hang on. I'm going in steps. So what I want to do is I want to get a 0 here. Okay? And I can do that by adding this and this. Okay? And that's fine because I won't have to reintroduce numbers anywhere. So I'm going to add R1 plus R2. And I'm going to get 1, 0, 1, and 8. Also, for row 3, I just want to divide by minus 1. Or multiply by minus 1. Negative 1 times R3 gives me 0, 0, 1, 7. Okay, so let's see what else we have left.
0, 1, 0, 5.
So here I have, you can, negative 1 times R3, just to get rid of the negative. Okay, I just have that 1 left. For that, I'm going to do row 1 minus row 3. Okay? And I get what? 1, 0, 0, 1, and the rest is the same. And that's it, you're done. So now this is a matrix in reduced row echelon form. And now all I have to do is look to see that x is equal to 1, okay? Y is equal to 5, and z is equal to 7. And of course, I write it in coordinate form, 1, 5, 7. And that is my answer. Okay?
Another one.
All right. Okay. So, okay. Sometimes you can't write the matrix in row echelon form, in reduced row echelon form. In that case, you have two situations. Either it has no solution or it has infinitely many solutions. So remember that when you are trying to find the solution of a system with 3 equations and 3 unknowns, each of those equations represents a plane. So you have 3 planes that, in this case, the 3 planes meet at a single point in space. Okay? Sometimes the planes can all be parallel, or you could have 2 that are parallel and one crosses the other 2. Not all 3 meet at the same place. Sometimes you can have, like the pages of a book, 3 all meeting on the same plane, on the same line. That's when you have infinitely many solutions. All right, so let's start solving this one. We're going to solve it using Gauss-Jordan elimination, and we're going to write the matrix first. Okay. So go ahead and start doing this one. Oh no, what did I do here? I made a mistake here. So here, I want to write this here. I'd like to do row 2 minus row 3. So 0, 0, negative 2, 0. Would it?
Yeah. Oh wait, I thought. You write everything. No, but wait, why did you write for row 2 in your second bracket 1, 1, 3? I got 1, 2. Yeah,
so 2 row 1 minus row 2, 2 minus negative 1, that is a 3, right? So here, there we go. So here we get 0 everywhere, okay? Now, what this is saying is 0 equals 0. When does 0 equal 0? Always. So this is one with infinitely many solutions, but but you don't stop here. Okay? You don't stop there. What you have now is this. X plus 2y plus z is equal to 8. And you have y plus 3z is equal to 3. Okay? But you don't have any information for z. No. You don't have any information for z. All right? Now, here's what you do. Because You don't have any other equation here for z, okay? What you want to do is you want to solve each of these for the other variables. So solve this one for y. Okay, when you solve that for y, you get that y is equal to 3 minus 3z. Okay? And now we're going to solve the first equation for x. And substitute y. So here's what we're going to do. X equals negative 2y minus z plus 8. Okay? But how much is y? 3 minus 3z. So this is negative 2, 3 minus 3z minus z plus 8. So basically, I want to solve all of them in terms of z. And here I get negative 6 plus 6z minus z plus 8 equals x. So x equals 5z plus 2. Now, what's the final answer then? The final answer is x comma y comma z, right? X is 5z plus 2. Y is negative 3z plus 3. And z, I just put in z. And that's the final answer. Okay, so depending on what z is, you can have many, many different possibilities. Yeah. Okay. All right. Next, let's do this one. So the matrix is going to be 2, 3 minus 1, 1, 1, 1 minus 2 and 5, 1, 2, 1 and 5. All right, I want to get a 0 in the bottom left corner. So I subtract row 2 minus row 3. And I get 0 minus 1 minus 3, 0. What else do I want to do? 1, 2, 1, 8. Negative 3. Okay, next, I want to get a 0 in this one here. All right, so I'm going to do row 1 minus 2 times row 2. So I get 2 minus 2 is 0, 3 minus 2 is 1, negative 1 minus negative 4 is 4, 3. Yeah, so it's 3. And here I get 1 minus 10, negative 9. The top row will remain unchanged for now. Then I want to get a 0 here, so I just want to add the 2. Okay? When I add the 2, right, R2 plus R3, I get 0, 0, 0, negative 12. Okay? When does 0 equal negative 12? Never. So no solution. That's it. All right? Now, this homework will be due next time I see you, so Monday, I believe. Is next week? Okay.